we have completed up to module 2, right? So we are moving forward to module 3. Now we are moving to actually to work with a microcontroller right now. So now we will, till now we just studied the theory, and then we understood the concept that we learned with respect to embedded C in general C in our laptop right now using GCC we have learned.
Yeah.
Now we are going to really going to program for a target, and we are going to use the target to design a automotive ECU. That is our plan. That is our goal. So in that goal, before moving to the actually developing the project, let us understand each peripherals of this microcontroller and then how to program them. And then we will connect the dots to create a project, right? So that is what the aim. When you want to learn a microcontroller or microcontroller, what we used to, I think, because it's joining, okay. So we used to study the data sheet. Data sheet is the key to, one sec. Data sheet is a key to understand a microcontroller, right? So only then we can learn how to work, how to program that microcontroller. We have to know the memory detail, peripheral details, port details right now. So only then that is possible to, only then we can program it right now. So in that level, let us first define what is the chosen target for our project, as we were well versed in this 16F877A, as it was my controller that you used in my MTech project. Right. So we want to use the same now. We want to explore other microcontrollers as well, but when we do course, it is if we have something, if you know or do projects in a controller which in which we are well versed, we can do things very easily. That is my plan. That is why I chose this particular controller, right? Because I know this controller to some extent. So slowly we want to migrate to other microcontroller which is having inbuilt CAN, that we will move forward. That will look in the later point of time. Right. As of now, the target chosen is 16F877A. It is a 8-bit microcontroller from Microchip, which is having a flash as memory. We had studied EEPROM memory, and then EEPROM memory, and then flash memory right now. So this particular microcontroller doesn't use, it has EEPROM, but for program, to store program, it uses flash, right? That is the thing. That is the beauty about it. It has nearly 3 timers, and then it also has a capture, compare logic, compare and PWM modules are available. And then it support synchronous serial port, serial peripheral interface, I2C, USART, SCI. So like that, there are a lot of benefits that we have in this particular microcontroller. So those are aligned to our project requirement, because our project need lot of ports. Because we are going to drive lot of IO pins for various telltales, right? That means telltales is an annunciator in a electronic control unit, which alarm the driver about a failure or some fault, right? Have you heard about telltale before in the past?
Yes,
What
sir.
you heard about telltale?
Yes,
Yes,
sir.
sir.
What you know about telltale, Vikas?
Yes, Telltale is a icon. Some of the icons that will be present in the cluster,
Okay.
where we will get to know about some faults.
Okay. When there is some fault, Actually, how these annunciator are actually annunciator means glowing of an LED behind an image. That is what annunciation. Also, it is used to infer something. Then that is called as annunciator. Right? This is a technical term. Right. In automotive industry, they call those annunciator as telltales. Right. Because it is specified in automotive standard for any country. So they use the name. Again, the automotive industry also follow the same. Right. Telltale is just like a lamp which is glowing behind the scene. That means some image. Let me show you some telltale images in a meter, how they used to look like. Right. Then we will proceed. We will have a common understanding. From there we can proceed. Right now. So in this instrument cluster, we are seeing airbag telltale and then seat belt telltale, ABS fault telltale, check engine telltale, right now engine fault telltale, left and right indicator, adaptive cruise control telltale, and then I believe this is heater, something like that. So like that, we have different telltales in a instrument cluster right now. Actually, how these clusters are implemented, these telltales are implemented, do you know? Actually, if you look at this, there will be a transparent film which depicts this particular image. Behind that, they used to glow a red telltale. That's all. Red LED. For this particular thing, the same transparent stencil or something like that. Behind that, they used to glow a green LED. Here it is amber. Like that, they used to glow different colors of LED behind a image right now. So that is how the telltales are implemented. So if you look at very closely in a microcontroller, to turn on using a microcontroller, if we want to glow a LED, what we used to do in my microcontroller program? Any idea? I have a microcontroller program. I have a microcontroller. Using that, by writing program or by writing certain, when the certain condition is satisfied, the microcontroller should turn on at LED right now. So how we can achieve this? Any idea?
So, if the microcontroller receives any CAN message, so
Okay, forget about CAN communication at all. Now only we are talking about output. After we get the fault, after the system knows that there is a fault, my question is very simple. How to write program to turn on a tell LED which is interfaced with the microcontroller? Otherwise, I can put the question in other way. How will you interface a LED with microcontroller? This is more straightforward. I think answer of this one lies in that one.
we are connecting a LED with one of the I/O port,
Brilliant. So in a
resistor.
microcontroller, we used to have number of ports. Those ports are I/O pins right now. For to those I/O pins can be those are controllable using program. When we want to glow a LED, we will make that particular pin high or low, because in some LED you have to supply low voltage, active low to the pin in order to glow the LED right now. In some microcontroller, you have to supply high to make the LED to on. That is how embedded programming works in different controller right now. So anyhow, we have to use a digital I/O along a digital I/O pin of microcontroller, along with some housekeeping circuitry like resistor, LED, and other stuff right now. So that is how even in industry these LEDs are implemented. This is not a big rocket science. They are not, they use a different big logic to make these LEDs to glow. If you just remove the skin of the meter in the motherboard of the meter, you will find the LEDs in these locations. Right. These LEDs are in align with the transparent skin, which is having different telltale images. Right. It aligns when they fix it. Right. And then using program based on the CAN messages, whatever it is, when they make that pin high or low, that particular telltale glows. This is how it is programmed right now. So we have to, when you want to work with the microcontroller, very first step that you will do is you will try to make certain pin high or low using program. They used to call that flag toggling program. In every microcontroller, microprocessor, the very first program that they will try is that one only. After that only communication, ADC, DAC, and the interfacing of external peripherals, all those things will happen. Because first thing is we have to know whether the microcontroller is really working or not. Because you may make mistake in choosing the crystal oscillator for the microcontroller. You may made some of the critical pins in a wrong connection, something to be connected with the battery, but you have connected with the ground. So these are possible, no? In real time, these defects are very much possible. So after making our hardware in place and after we flash the program, we have to ensure that whether the microcontroller is working without any issue. Only then we can do a complex program, right? Very first time what we used to learn, first we learn A, B, C, D, something like that in a language before we write an essay in that language or before we give a lecture on that language. Right now, we will try to write that language in a simple way, or we will try to pronunciate that language in a simple way. So same thing to implement, to understand a microcontroller is working or not, we used to drive the program. We used to drive the port pins to toggle. We used to drive the port pin to toggle so that if it is toggling as per the program, then the microcontroller is functioning. Then we can implement the complex logic. Right. So once we complete our exploration of our data sheet, we will be doing that port control, a basic access. From there, we will go to the next steps, one by one, log to digital converter ADC program.